Okay, number 45. Let's find the derivative of this fraction. Let's get a bigger idea. This is a fraction, so we follow the rule for derivative of fractions. We would say derivative of the numerator, the entire thing, times the denominator, minus derivative of the denominator times numerator, divided by denominator square. Okay, so let's follow that idea. Y prime is equal to derivative of the numerator. So I'm going to write the numerator for now. Derivative of the numerator, which we're going to find that, times the denominator, minus derivative of the denominator. So that's easier to find, so let's find that. Derivative of the denominator, you just take 7 to the front and then subtract 1. So x plus 3 to power 6 times derivative of inside, which is just 1. So we don't write anything. Derivative of the denominator times numerator itself. Divided by denominator to power 14, because you would say x plus 3 to power 7 to power 2. Okay, so let's continue that. Y prime is equal to, so now let's find derivative of this first piece that we had. So now you see multiplication. Think about derivative of the first one, which is radical x plus 1. So let me rewrite radical x plus 1 as x plus 1 to power 1/2. So we bring 1/2 to the front and subtract 1. So it's 1/2 x plus 1 to power 1/2 minus 1 is negative 1/2. Derivative of the first one times the second minus, actually plus, still we are working on that red piece, plus derivative of the second one times the first. To find derivative of the second piece, you bring that to the front of the parentheses. So that would be 5 times 2 minus x to power 4 times radical x plus 1. And we need to write and carry the rest, everything else we had here. So we need to rewrite them. There's not much room here. So I'm gonna write this in parentheses for that red piece, copying down x plus 3 to power 7 minus then bringing the second piece down. So there's not much room to copy it down, but the entire thing there would be copied. And then denominator, x plus 3 to power 14. Okay, to just simplify here, y prime. There are many ways that you can simplify here. One way would be to multiply the numerator and denominator, because this is like 1 over square root of x plus 1. So in order to get rid of that radical in the denominator, it's nice that you multiply the entire top and bottom by radical x plus 1. Okay, so then you would have radical x plus 1 multiply by 1 over radical x plus 1, so they cancel, means that cancels with radical x plus 1, so you would have 1/2 times 2 minus x to power 5. Okay, so I'm going to write that. If you want to get rid of 1/2, which also is going to be nice, then we can multiply this by top and bottom by 2 radical x plus 1. That would be even nicer. So then when we are multiplying, 1/2 and 2 cancels, and then radical and 1 over radical cancels. So what remains on the first one after cancellation is just 2, it's just this one, 2 minus x to power 5. On the second one, so you're distributing this 2 by 5 is 10. The radical by this radical here, so the radical disappears. So what you're going to have left is plus 5 times 2, we said 10. 2 minus x to power 4. And then radical and radical would be radical removed, so it's x plus 1. And then everything multiplied by x plus 3 to power 7. We still are multiplying this radical to radical x plus 5 since it's by everything. So it would be by the next radical that we said we're going to copy down at the bottom. So I'm going to copy down things, negative 7, x plus 3 to power 6. Radical and radical simplifies to just x plus 1. And then 2 minus x to power 5. In the denominator, x plus 3 to power 14, but also 2 times radical x plus 1. Okay. X plus 3 to power 14 could simplify more. If we factor x plus 3 to power 6 on top, part of that cancels with the bottom. So just factoring x plus 3 to power 6 from both of the top. So if you remove that, take it out. And then also if you pull x plus 3 to power 6 of this, so you will have only x plus 3 here because the remaining will be pulled. So, and then x plus 3 to power 6 could cancel with that to power 14 as of x plus 3 to power 8. Okay. So that's equal to, so rewriting it, so it would be as of the final, so this would be 2 minus x to power 5 plus 10, 2 minus x to power 4 times x plus 1. And again, you can simplify this a lot more depending to how much time you are putting for simplifying. X plus 1, 2 minus x to power 5, all over 2 radical x plus 1, and then x plus 3 to power 8. Okay. Next, and you can leave it there in the test. Remembering that this one should be in bracket because that x plus 3 belongs to both. Okay, and again, you can simplify a lot more. I encourage you to do that to see it. So next one, 55, finding f prime of t and then f double prime of t and then finding f double prime of 2. So that's 4t plus 1 to power 1/2. So you bring 1/2 to the front of the parentheses and subtract 1. So it's 1/2 4t plus 1 to power negative 1/2 times derivative of inside, which is just 4. Okay, so that is equal to 4 and 2 cancels to 2. So 2 4t plus 1 to power negative 1/2. Finding f double prime of t. So we bring negative 1/2 to the front of the parentheses, multiply that together, and subtract 1 from here. So the result is 2 times negative 1/2 is negative 1. 4t plus 1 to power negative 3/2 times derivative of inside. Okay, now we want to find f double prime of 2. That is equal to substituting 2 for t. Okay, that's negative 1. 8 plus 1 is 9 to power negative 3/2 times 4. To simplify this, first we need to take that to denominator. So on top we have negative 4 as a result of 4 times negative 1. On the bottom we have 9 to power positive 3/2, which is 9 to power 3 square root of that, which that is negative 4 over square root of 9. Square root of 9 is 3, so that's 3 to power 3, which is 27. And that's f double prime of 2.